Hello everyone, this is Kinetic Tutoring, and on this channel I'm going to be teaching you guys how to solve physics problems step by step. This channel is mostly going to be focused on AP Physics C, but if you guys have any similar questions, make sure to leave them in the comments below and I will make sure to do my best to address them in future videos. Now, without further ado, let's get into this problem on the screen right here. The prompt tells us a long thin rod of length L has a linear density lambda of x is equal to a times x, where x is the distance from the left end of the rod. Part A of the problem is asking us how far is the center of mass of the rod from the left end of the rod, and part B is asking us what the mass of the rod is. Now let's set up a simple diagram just to get a better visual of the problem. Here's our rod, and it is going from length 0 here to length L over here. Now, from solving this problem, I came to realize that it makes more sense to solve part B first because it makes solving part A much more efficient, as if we have the mass, finding the center of mass becomes much less of a hassle. So let's start with part B. We're given that linear density is A times x, and we know that density is simply mass over area, so our density could be written as dm over dA, and we can set that equal to ax. And since we're talking about a rod, a very thin rod, that means that our area can be simply written as the length of the rod, which is x. So we can swap the a out with an x. And now what we want to do here is get the dm by itself in order to solve for m. So we're going to multiply both sides by dx, and we'll get that dm is a times x dx. And from here we're going to integrate both sides in order to find our value of m. On the left side of the integral we'll get m, and the integral of ax dx will simply be ax squared over 2. Now that we have our mass, we can move on to part A of the problem, which is asking how far is the center of mass of the rod from the left end of the rod. Here we're going to have to incorporate our center of mass equation, which is simply 1 over m times the integral of x dm. Now, since we have already found our dm and our m, we can just plug those values in and we should be able to find our center of mass. So we'll do 1 over m, where m is ax squared over 2, and integral of x dm. So we'll write x, and our dm is ax dx. So let's make this equation look a little simpler. We know that 1 over ax squared divided by 2 can be just written as 2 over ax squared, and we can multiply these two x's together, and the inside of the integral will be ax squared dx. Now we can move this a outside because it is a constant, and after we do that we will get 2a over ax squared times the integral of x squared dx, which will be 1/3 x cubed. From here, our last step is to cancel out common terms. We have an x squared here and an x cubed here, which will leave us with an x on the top, and we also have an a on the top and the bottom. So on the top we'll have a 2x, and on the bottom we'll have a 3. And this will be our center of mass. Now the problem probably wants it in terms of L, but we know that x is just the distance from the left end of the rod, so X and L are basically interchangeable. So we can just swap out this X and write it as 2L over 3 as our center of mass. I hope this helped, and make sure to tune in for more physics tutorials. I'll see you guys next time.